I'm Mark Kenyon with Garage Gurus, and today's tech tip, we want to talk about how to properly do a cylinder leak down test. Before we do that though, let's talk about why we would do a cylinder leak down test. And the reason for that is we're looking for some kind of sealing problem inside the cylinder, whether it's a piston ring that's been damaged or piston through maybe a detonation situation, a valve leakage situation like an intake valve, or maybe an exhaust valve that's not sealing anymore. These are all things that can cause cylinder seal problems, which then will show up as cylinder misfires, and it's more of what we call a mechanical problem. So we're going to address it more from a mechanical diagnostic this morning. And make it a little easier to film, we decided to use this motor that we have that's on an engine stand. Same technique that we're going to use here is what you'd use in the vehicle, obviously. And this is a 2-liter Ford, came out of a 2018 Ford Fusion hybrid vehicle. So there's really not a whole lot of high technology on this. We do have VVT, but there's no turbo, there's no direct injection, just pretty much your standard 4-cylinder motor that Ford produces. The first thing we're going to want to do is we're going to want to remove the the ignition coil for the cylinder we want to test, and then we'll remove our spark plug, as you can see right here. And then we have a hose that we're going to put into the cylinder, and this hose is going to connect to our leak down gauge. Now, the big struggle with this is getting the piston at top dead center on the compression stroke, okay? And there's a couple of ways to do that. You can see on the front of the motor here, I have a breaker bar connected. And what I would do is, in many cases, I'm going to put the hose in the cylinder. Okay, let me get this down in here, and it's plenty long. And we'll get it in and kind of get it snugged up. And then I can put my thumb over the end of the hose and actually rotate the motor. You know, remember to rotate it clockwise. And rotate that and feel the cylinder pressure come up. And when I feel that pressure building, just keep moving and keep putting my thumb over this until I feel it kind of stop building pressure. Then I know I'm going to be right at top dead center or very close. The second part of this is you may need an assistant to actually hold the crankshaft, because if you're not perfectly at top dead center, then the piston will want to turn. The air pressure we're going to put in there is substantial enough that it would push the piston down. If you do happen to get it perfectly at top dead center, when you put air in there, the crank won't turn, and I've been able to do that. Another helpful tool may be a LED light. This one has a real bright light on the end, and I can actually look down inside that cylinder through the spark plug hole and actually see the piston and rotate that again, as I said, until I get it to where it's perfectly at top dead center. I see it come up and I see it stop. And that stopping is just before it changes direction. That's what we call our dwell time. And if we get that rod perfectly straight up and down, obviously we're not going to get it to push or move when we put the air in. And that's kind of where we're at now. So the setup is, let me review that real quick. Basically remove the coil, the plug, put your test hose in, crank the motor over until you feel it get up to top dead center. If it's close, or if it's accessible enough that you can get down in there with your light, there again, rotate the motor slowly, watch the piston. You should be able to see it, and I could on this one, see it come up, and when you get it to where it's at that point where it doesn't move anymore, now you know you're in the proper position for testing. Right? What I want to do next is go ahead and set up the gauge. So let's get started on that. Okay, let's go ahead and get the gauge set up like we talked about. What we're going to want to do is connect shop air to this fitting right here. Okay, and the instructions on this gauge assembly says they want you to, let me get my hands kind of situated here, and I need to be able to see what I'm doing, is I want to turn the regulator, okay, until we see basically 0 on our leak down gauge over here. So let me go ahead and crank that up. We're turning it and we're watching our leak down gauge. We want it to be on the 0. So let's get it over here. And you can see it's going to be roughly about 100 psi of air pressure inside the cylinder. So you can see right there, we're in pretty good shape. Notice we have about 100 pounds of shop air coming in, and we're zeroed on this gauge. The reason we're doing this is we're gonna look for a percentage of leakage, and we're using 100 pounds as our basic 0 point. So when we move back from this number here, whatever the amount of leakage is on this motor is gonna be read in percentages, okay? If there was no leakage at all, it held the whole 100 PSI of pressure, then we would see 0 on the gauge. If we see 10% leakage, okay, even though we still stay at 100 PSI here, now 10 PSI of that, or 10% of it, I should say, is probably better, is actually leaking past something inside the motor, more than likely the piston rings, okay? Usually a valve leak or a hole in a piston or a damaged piston or a damaged ring is gonna have a substantial amount of leak. The question a lot of times I get from techs is, how much leakage is acceptable? And I'm gonna say between 10 and 20% is usually where I wanna be. I first started doing this, I don't even wanna say how long ago it was, but it was back in my racing days. And what we would do is halfway through the season, we would actually do a leak down on the motor in our dragster, and that would determine if we were gonna tear it down and re-ring it. And we typically would have less than 10% leakage, which was a good number for us. Now we're also talking about a hand-built motor that was designed with very specific tolerances. An actual production engine might hold that good, but it might just be a little bit more. So somewhere between 10 and 20% is really what I see as acceptable. Now, we've got our gauge set up, we've got our air coming in. So all we need to do at this point is basically just connect these two together. And so let me go ahead and get this hose connected in here. All right. And we can see this motor has quite a bit of leakage. Now, this motor's been sitting around in our shop for a long time, and obviously it hasn't been driven, so rings are probably not sealing because there's probably no oil left on the cylinder walls, and valves are probably not sealing real well either because it's been sitting for a while. There's probably a little bit of rust buildup on the inside of the motor. But you can see what it looks like when you've got about 85% leakage. The next part of the step would be to determine where is that leakage coming from, okay? Is it through the intake valves? Is it through the exhaust valves? Is it through the crankcase because the piston rings are leaking? Or is it the cooling system? You know, I got a head gasket leak where I'm gonna have to look at, you know, do I have air coming out of here? In many cases, the motor would be full of coolant at this point, so we'd actually pop the radiator cap and look for bubbles. So here's what I want to do. Let me set this down for a second. I'm going to remove this oil fill cap, and then what I'm going to do is I'm going to take my lapel mic, and I'm just going to put it in different places so you can see if you hear where it's leaking from. So let me go ahead and remove this. All right, let's go ahead and do the intake side. And then I'm going to do the exhaust. And you can tell by listening right there, I got leakage everywhere on this motor. With this much percentage of leakage, it doesn't surprise me that it's crankcase through the intake and through the exhaust. There again, as I said before, this motor's been sitting for quite a while, and it's just not sealed up. That's pretty much all that we have on this tech tip for you today. I'm Mark Kenyon with Garage Gurus. For more information about Garage Gurus, check out our website, garagegurus.tech. And for more helpful tech tips like this, subscribe to our YouTube channel. Thanks.